Hello friends, this time we will see this video about let f be a function defined by f of z. They have given a nice sequence and show that f defines a characteristic function of the set 0. So before that, let us see what is the characteristic function means. So it is a, we call indicator function, sometimes some authors calls indicator function also. So Cantor set indicator function is one of the very famous function, which is also in a real analysis very important in analysis, which says that it is Riemann integrable. Okay, irrespective of its totally disconnectedness, it is Riemann integrable. Okay, so it's one of the very important example which serves as a Riemann integrable. Okay, so characteristic function also plays an important role in distinguishing Riemann integration and Lebesgue integration. So let us understand what is characteristic function. So I have a set, let's say non-empty set. I start with that A and x is non-empty set and A is contained in X. Let us say that this is also non-empty for simplicity. I don't want to be very complicated right now. Then I define a function, usually it defines like this, fa. So from x to 0 and 1, so the value f of x is 1 if x belongs to A. If does not belongs to A, then it's 0. So it's just a testing function. So the value is takes 1 if it is inside, right? The value is 1 if it is inside A. So it entirely depends on A. So each A corresponds to a function fa. So you can ask me what is the empty set correspondence to. So the empty set's correspondence to, when this is empty, it's completely 0 everywhere. So this is a function. So every subset corresponds to A. So it means there is a correspondence between the power set of this one and this, the characteristic functions. So both are set theoretically equivalent in a sense, set theoretically equivalent. Okay, so from that one can go from here to here. So this is what characteristic function. And the problem is, so they have given that f of z equal to limit n tends to infinity 1 divided by 1 plus n square z. So we have to prove this is a characteristic function, okay, of 0, the set 0. So we are in complex, so we have taken the 0. So solution, we are in complex and we have taken 0 and this is our set. So the question is prove that. To prove 0 is this f. So we know f of 0, since what is f is 1 divided by 1 plus n square z. Okay, so f of 0 is obviously 1, so it takes 1 at the point and he agrees with the characteristic function. So okay, if z not equal to 0, what we have actually, since z not equal to 0, and for large n we have this following inequality which says that mod n square z, this is like A, for large enough, this is n square z. Okay, n square z mod minus 1, and this is greater than or equal to 1 by 2 n square z. Okay, when you reciprocate, since remember that z not equal to 0, and when z is not equal to 0, this is not equal to 0. So when you just reciprocate, what happens that we get 1 divided by n square z plus 1, which is less than or equal to 2 by n square mod z. Okay, so as n tending to infinity, this approaches to 0, right? Because it's a dividend. These are just constant, fixed constant. So this approaches 0 as n tending to infinity. So that means this is also goes to 0. So that implies f of z is identically 0 if z not equal to 0. So that says f of f is identically to the characteristic or indicator function of this thing. Okay, thank you. I will see you in the next video about more problems of complex analysis. Thank you.